Alright, in today's video, we're going to tackle the structure of an atom's electron cloud. So if you remember, the protons and neutrons are located where? If you said nucleus, you are right. Nice job. But remember the electrons. We saw the Bohr model of the atom that says the electrons orbit like planets around the sun, going in circles around the nucleus. But that, it turns out, is incorrect, because an electron is more than just a particle. It also has some wave properties. And because of that, there's some uncertainty where a electron will be in the next second, or the next millisecond, or the next microsecond, or whatever unit of time you want to use. But we gave the analogy in the last video of the firefly in the dark room. You're never sure where it's going to be, and that's how we think of an electron. So let's take it a step further, and I'm going to introduce in this video the idea of an orbital. An orbital is the actual space inside an atom where you are likely, and that's a key word, where you are likely to find an electron. So let's take a look here. We have I have a picture, and we'll take a look at A here. And this is an electron probability cloud. Okay, and we remember from the last video, it's dark in the middle because the electron is likely to be close to the nucleus, and it gets less and less likely, or less and less dense as you get out, which means as you get further from the nucleus, you'll find an electron that far away from the nucleus. It's possible, though, an electron could end up out here or over here, really far away, but it's likely to be here. And we define an orbital. So an orbital, so I'll write this here, an orbital is a sphere, whoops, which has a 90% probability of housing an electron. So an orbital, here's our word, is a sphere which has a 90% probability of having the electron in it. So this is hydrogen's orbital. So what we can say is, if this is the space where 90% of the time the electron spends its time, then we can make it a solid sphere and say that that is an orbital. Now, there are different types of orbitals, and that's our next topic. So the orbital we just were talking about is spherical, and it is what is known as an S orbital. Okay, but it turns out that if we look at an atom, any atom, but especially hydrogen, well, we're looking at hydrogen here, but any atom, that there are levels. You can think of the electron cloud of an atom as a multi-story hotel. So, and the floors of the hotel are, in the atom, are called energy levels. So we have the first energy level, right, or principal level 1, and it's at the very bottom. This is closest to the nucleus. Closest to nucleus. And then we have a second energy level, or principal level 2, energy level 3, energy level 4, and so on. As the energy levels get higher, the electrons in those energy levels get further away from the nucleus. Now, inside each energy level are different types of orbitals. So, let's take a look at this pyramid, which represents the different energy levels. So, inside energy level 1, we just have an s orbital. So energy level 1 just has this orbital. Okay? Energy level 2 has an S, and it has a second new type of orbital. And what's new about it is that it has a new shape, and it is known as a p orbital. So this is an S, this is a P, this is an S. So then we get to the third energy level here, and we have an S, a P, and now this orange one we can call it a D orbital. And then we get up to the fourth energy level, and we have S, P, D, F. So we have 4 kinds of orbitals. I like to tell my kids to remember the orbitals. You can remember this saying: some people don't forget. And this is for orbitals. S, P, D, and F. So S, P, D, and F. And let's take a look in the next slide at what this looks like. So if you remember, the S orbital is looks like a sphere. A P orbital looks like a peanut. That's not why it's called the P level, but it's a P orbital. But that's an easy way to remember it. And you can see what's different about the P orbital is that there, instead of just one, there are actually 3. So there's one that is oriented around the x-axis, and if you look, here we have our electron probability cloud, or our density cloud, and then again, close to the middle. But what is interesting is that for the P orbital, there is 0 chance that you'll find an electron at the exact center of the orbital where the nucleus is. And the reasons for that are mathematical and really at this point beyond what we need to know. But just remember that for the P orbital, there's no chance that you'll find an electron at the nucleus. So you can see you have these peanuts in all 3 directions: the X, the Y, the X, the Z, and the Y. And so if we go down to this picture, we see on the first energy level, if you remember from the last picture, we have just an S orbital. On the second energy level, we have an S. And notice that as you go up energy levels, the orbitals will get slightly bigger. In other words, this 2s orbital is bigger than the 1s orbital, and it makes sense. This 2s orbital contains the 1s orbital. It's inside of it. It's smaller. This is the electron cloud, remember. So if we looked at it, maybe here would be the 2s, here would be the 1s. And so, and then maybe we would have the 3s out here. Okay, so it's kind of like maybe, or another way to think of it is, this is a ping pong ball, this is a tennis ball. You'd have the ping pong ball inside the tennis ball. And then also on the second energy level, you'd have these p orbitals. So they would be, you know, I can't draw in 3 dimensions, but something like this. Right? And if you take these as a whole and put them together, they also make a spherical shape. It's hard to see, but if you take this here, and then you have one here, it makes a circular shape. We'll do something in class to kind of help you visualize that. But notice on the second energy level now, we have 4 orbitals. 1s, and then 3 p's. Okay, and the last part to notice here is the way we name the energy levels. So the number will tell you the energy level. So 1s, 1 means it's on the first energy level or the first floor. It's closest to the nucleus. S tells you what type of orbital. 2, second energy level S, or here we have second energy level P. And then the little numbers here tell you in which direction, if it's a P orbital, which direction it is facing. Okay, and this video has a lot of information. I suspect you'll have to watch it a couple times, and as the next few videos go, I'll explain this again and again so it'll make sense. This is the most conceptual part of chemistry. But let's look at the D. So if you remember, s orbitals, you have one of them. p orbitals, you have three of them. Now let's look at the d orbitals. There are 5 of them, and we can see them right here. And again, at the center where the nucleus would be located for a d orbital, there's no chance that you'll have an electron, that you'll find an electron at the nucleus. And their shapes, when put together, and I can't draw this, but if you could put this shape and superimpose it on this shape, on this shape, on this shape, on this shape, it would also make a sphere. Okay, you don't have to know their directions because it doesn't really make sense to us. But just know that the D's don't come into play until the 3rd energy level. And if you think back and you remember, on the 3rd energy level, we have 3 different orbital types. Now the types of orbitals, well, this says 3 sublevels. That means there's an s sublevel or an s orbital, a p sublevel, and so an s, a p sublevel, and now a d sublevel. The d sublevel has 5 orbitals inside of it. These are what they look like. Now, when we get to the 4th energy level, there is an s sublevel, a p, a d. There's also an f. You can probably guess when we have f orbitals. Maybe you see a pattern here. If you don't, 1, 3, 5, we're going to have 7 f orbitals. So this is 1. Let's do that in black. This is 1, 3, 5, 7, 1, 3, 5, 1, 3, 1. And the F's are very complicated. The book doesn't even attempt to have a picture, so we won't get into what they look like. But that would be an interesting, if you want to go for the advanced points on the SSS or the advanced assignment, the F orbitals would be a good exploration for you. Alright, that is today's video. Again, watch it as many times as you need. It'll make sense over time. This takes a little bit of watching to kind of get it.